I believe this will be the final video. Keeping in mind here we have all of our properties of exponents that we've been talking about, nicely written up there. But so for example, numbers 9 and 10, exponential form and simplest radical form. Well, I'm not quite sure what I don't remember what I'm supposed to be doing here. I'm thinking that these are two separate problems. So we're going to treat them as two separate problems. And so we have the square root of 8, and we know the square root of 8 can be written as square root of 2 times 2 times 2. And we're looking for groups of 2, just like go fish. We bring a group of 2 out, and we have 2 radical 2. Well, that's simplest radical form. Cube root of 4 is simplest radical form. But then how would we write this using exponents? Well, 2 radical 2 is the same as 2 times 2 to the 1/2. So that maybe that went a little fast, not sure. But we know that radical 2 is the same as 2 to the 1/2 because that root is a 2, the exponent is a 1, and you write the exponent divided by the root, 2 to the exponent divided by the root, and that's what we talked about in the last video. So we can rewrite that radical 2 as 2 to the 1/2, and then we're going to use the property of when you have the bases are the same. If you notice right up here, when the bases are the same, you add the exponents. And so 2 to the 1 times 2 to the 1/2 is 2 to the 1 plus 1/2. Then we want to make sure we have the similar denominators. So we want to have a lowest common denominator. So we're going to have 2 to the 2/2 plus 1/2, which is 2 to the 3/2. So 2 to the 3/2 is the simplest, or is the exponential form, and 2 radical 2 is the simplest radical form. Well, this one over here we have already simplest radical form, and we want to write that as 4 to the 1/3, and that is in exponential form. I suppose you could write that as 2 squared to the 1/3, which is 2 to the 2/3. So I would take either one, 4 to the 1/3 or 2 to the 2/3. Either one is fine. And now for the grand finale here, we've got, as you can see here, the 5th root of 27 to the 3rd power. Well, good grief. There's a lot here. There's a few different ways actually to tackle this one. What I'm noticing is that I've got the same root right there. Now, the same root means that I can go ahead and combine them, 27 cubed over 9 squared. I can combine them. Remember, under one radical. And then I'm noticing that both 27 and 9 are powers of 3. So if we get a little bit creative here, we can save ourselves some work. I don't want to multiply 27 by itself 3 times, but what I will do is I'll rewrite 27 3 times, and I'll write 9 twice, because I know that 9 goes into 27 3 times. 9 goes into 27 3 times. So I'm canceling like factors. In fact, if that doesn't sit well with you, let me just expand it one more time. I can take each of the 27s and I can write them as 3 times 9. I'm going to save the last 27 because I only have 2 9s down below. So all I'm doing is rewriting, just factoring the factors that are already there. 27 again is 3 times 9. I know that 9 divided by 9 is 1. And again, another 9 divided by 9 is another 1. And so we have 27 times 9. And 27 times 9, I want to make sure I get this right. 9 times 7 is 63. 9 times 2 is 18, plus 6 is 24. So we have 243. But actually shouldn't have done that, because what I see here now, let's simplify here before we go any further. The 5th root of 3 times 3 times 27, and that's all over 1, so I'm just not even going to write that. I'm going to leave it like that. 3 times 3 times 27. And remember from last week, we want groups of 5. Well, again, we've got that 27 can be written as 3 times 3 times 3. So we got really, really fortunate here. We have one group of 5, so that entire expression has a value of 3. So that actually is both exponential form and simplest radical form, 3. That's past 5-minute mark. I'd be curious to see here if we did something else. If you don't mind, you don't have to watch the rest of this, but I'm just kind of messing around here. The 5th root of, 27 to the 3/5. Let's say we did it the exponential way. 27 to the 3/5 over 9 to the 2/5. Well, let's then express both 27 and 9 as powers of 3. So here's another way to do it. So you have 3 to the 3rd power to the 3/5, and then you have 3 squared to the 2/5. Well, 3 to the power to a power, so you have 3 times 3/5. Well, that's 9/5. So you have 3 to the 9/5 over 3 to the 4/5. 2 times 2/5 is 4/5. And then we know that when the bases are the same, does it say that up there? Yeah, so right up here. We're going to use this property right here. When the bases are the same, you subtract the exponents. So we have 3 to the 9/5 over 3 to the 4/5 is 3 to the 9/5 minus 4/5. And 9/5 minus 4/5 is 5/5. Well, 5/5 is 1, so we have 3 to the 1, so we have 3. Any way you slice it, you get 3.